So without further ado, welcome to Lots of Little Mistakes, LLMs in Production. So it's a clever title for a clever technology. And I am John Dickerson. I'm a co-founder and chief scientist here at Arthur. I also wear a separate hat as a tenured faculty member at the University of Maryland, where I've done quite a bit of research sort of in the space of responsible machine learning and safety over the years in a number of sort of high risk application areas, especially in healthcare and finance. So I'll start with some motivational quotes, as we're wont to do. So one of these recently coming out of IBM. So IBM announced a plan to explicitly replace a large number of jobs with AI over time. And the AI is, LLMs is what they mean when they say AI here. So here's a quote from their CEO. I could easily see 30% of that being sort of white collar back office style work getting replaced by AI and automation over a 5-year period, which is both exciting and also pretty scary, right? Because we're talking about a technology coming in and disrupting a lot of traditionally fairly robust jobs and sort of these back office white collar jobs. Here's a quote from a study, arguably a little bit biased because it came out of Microsoft, but talking about GitHub Copilot. So Copilot is a language model that sits alongside your development environment and suggests very sort of sophisticated code completions, and more recently things like code summarization and explanation. The striking difference was that developers who used GitHub Copilot completed the task. So this is in a paper, a sort of traditional programming task, 55% faster than developers who don't use GitHub Copilot. And I don't want to put a lot of emphasis on 55% as a number, but talk to anybody who's using these sorts of copilots who sit alongside while you code, and you'll see that it really does boost productivity. It really does relieve some of that mental load of putting boilerplate code out there, and it can really do a very good job of often not correctly, but starting off a code base quite easily. And so this is exciting stuff. And there are other stories like this that we'll talk about in the coming slides as well. So I should define what a language model is before defining what a large language model is. And language models are definitely not new. There's a famous one called ELIZA from, 50 years ago now, basically. Language models sort of had their first renaissance moment in the 80s with the adaptation of statistical language modeling, and then really had a sort of moment of success in the last 5 to 10 years with the advent of deep learning and the ability to use very large data and large models to do things like language translation, summarization, and so on. But all a language model is, large or not, is a statistical model of the words in a vocabulary. So this can be the words in a language. And you'll hear folks talking about tokens. Right now at the very beginning, I'm just going to say words. You can sort of think of a token as a word. We'll go into that in a little more depth moving forward. So statistical model of the words in a vocabulary. And that vocabulary or that language could be, English or Spanish. It could be a form of English or Spanish, for example, Western English speaking Twitter, right? That's a very different set of words and a very sort of different distribution over those words than, for example, the Queen's English, right? Or it could be Java or Python or snippets of the human genome, right? Like these are all different sorts of languages that I could imagine having some sort of distribution over. And the basic task of a language model, again, large or not, is just to, given some sequence of words, what's the most likely next word, or what's a distribution over the words that are going to come after this, right? So the TLDR, if you want to know what a language model here is I'm just going to try and estimate the conditional probability of a word given some sequence of other words, or maybe the full probability distribution over all sequences of words, right? And then I can do things like sample from that distribution, or I can do things like ask questions like, what are the 5 most likely words to come next, right? Very, very simple idea. So let's make this concrete. Let's use one of America's most famed actors, Nicolas Cage, who has trained ConstitutionNet. And now he's interested in completing this sequence of words here, okay? And so I feed in a string. This is a raw string, right? Life, comma, liberty, comma, and the pursuit of. I need to do something like split that into different tokens or words that I feed into the model, but let's brush that under the rug for now. I'm now interested in what comes next, right? And so Nicolas Cage obviously has not read the Constitution, but he can use his model to determine that happiness is the most likely word to come next after the sequence. Okay, so I feed in life, liberty, and the pursuit of, and the model has some distribution over words that'll come next. Happiness has the highest probability, 10%. Property, maybe this is from an older version of the Constitution. Property has a pretty high, but still lower than happiness probability of coming next. Walking that down a little bit, democratic maybe, wasn't in any of the drafts of the Constitution in this particular point coming after that, but it's roughly in the same ballpark as that document, and so it has a reasonably high probability. And then maybe there are other words in the vocabulary that have vanishingly small probability of coming next, because this is a good language model. So in the case of Nicolas Cage, the probability of, for example, getting an Oscar after that is very, very low. Okay, so that's all a language model does. So a large language model, well, I mean, you can guess where I'm going to go with this, but is it just a larger language model? And I'll say yes and no. So at its core, it is indeed often much, much larger than traditional language models were. But there are some fundamental technological differences in the way that they work. So one of these is sort of architectural advances. The attention mechanism is a big one of these from a 2017 paper that came out. That's really driven a lot of sort of the transformer-based models that we're seeing these days that are pushing things forward, like the GPTs of the world, and the Claudes of the world, and the Bards of the world, and so on. Hardware advances have played a huge role here, right? And so this is commodity hardware, coming out of like the NVIDIAs of the world, as well as special purpose hardware coming out of, for example, like Google, has really allowed for the ingestion of large data sets, very, very high throughput when you're doing training, and the ability to do sort of highly parallelized or even like distributed training of these very large models. Much larger training data sets, right? So people like to say that, ChatGPT is basically trained on the internet, which, isn't entirely true, but it is trained on a very, very, very large data set, to the point where there are worries about running out of basically written text that can go into these data sets at some point, just because there hasn't been more text generated, which is very, very interesting and not a problem I would have foreseen, 10 years ago. And there's much larger data at inference time, right? And so what do I mean by that? Well, there have been a couple advances recently. So Mosaic ML put out a model, MPT, which can take as input 65,000 or more of these tokens, or you can still think of them as words. Anthropic just announced that they can take in 100,000 words as input, right? So this is like basically a book, like an entire book you can put as input into a model and then ask, both of these companies have used the Great Gatsby. If I feed the Great Gatsby into my model, what's the next chapter that would come out if there were another chapter to be written, which is just, I mean, that's incredible to see done. And these models can be very, very large, right? Like the large language model certainly is large. And so, this is just a sort of random image. These images are immediately out of date just because of the speed at which this field moves. But on the x-axis, I'm plotting time. So 2020, 2021, 2022, and we're having this talk now in mid-2023. And then on the y-axis, I'm plotting billions of parameters, right? So you can think of parameters as sort of these little knobs that I can tune or set in a particular model that will control its behavior. And so billions of them are set during the training process for one of these models, and then determine the output given a particular input. Okay, so parameters are not unique to large language models. This is just a term from standard sort of machine learning. But I'd like you to focus on that billion there, right? And so toward the very, very top of here, you're actually seeing models going into the trillions of parameters, which is enormous, right? In terms of space, and in terms of amount of data needed to train, and in terms of amount of compute needed to actually feed that data through the training process and so on. And LLMs don't always get larger, but they have recently been trending sort of upward in terms of the number of parameters, right? This is sort of an interesting direction of research, which is, can I get state-of-the-art behavior out of a large language model with 10 times fewer parameters than, for example, whatever the state-of-the-art models are, right? And so people have differing opinions on this. I'd love to hear that from the crowd as well, where you're coming down on this. But the hope is that we can get excellent performance, on the level of extremely large models, but in a much smaller sort of model, so we can run them on the edge or run them without using a ton of electricity, right, which is effectively equal to dollars and so on, right? But again, so basically they're just larger language models, right? And the tasks that they enable, right, the ability to generate text, the ability to summarize text, things like that, these aren't new tasks, but we're seeing them appear in industry at like lightning speed right now, because these models are so easy to use, especially when you're just hitting an API endpoint, and they do tend to work really, really well, right? Like much, much better than, say, 5 years ago. So I'll go over some of the other tasks that we're seeing here, but like the big ones that we're personally seeing in industry right now are summarization, right? Like reading Slack or Teams and giving some sort of like product manager or project manager style readout, or summarizing emails, full-on content creation, right? This is the idea that you can do like, marketing content to send out to potential customers, or customer service is a big one as well. And that can be external facing customer service, right? Maybe merchants are interacting with customers about a bill, or that can be internal customer service, right? This could be like an internal Q&A bot that allows you to, say you're at Bloomberg and you're running Bloomberg GPT, that allows you to query potentially private information within your firm. So quick aside here, many of us have heard the phrase foundation model, and I'd like to do a comparison here between foundation models and LLMs. So LLMs, what we've been talking about, these are some of the ones you've probably seen in the news. ChatGPT is obviously the big dog here. Google had a big announcement with Bard on Palm 2 recently, GPT-4 out of OpenAI, Chinchilla, which is a very sort of interesting set of models that talk about scaling behavior, basically, and a variety of others that I'm sure you've heard about. These are text to text, right? Sequences of text go in, and a token is predicted coming out. And I have here a nice GIF with a link to the paper that created it, showing the evolution of these different LLMs over time. And so obviously we won't go into that in this seminar, but I'd really encourage you to check that out. It's a really sort of interesting walk down memory lane. Now, foundation models include the set of large language models and more. Okay, so maybe you've heard of Meta's ImageBind, which came out recently, which takes, I think, 6 different types of input, like audio and text and image, and spits out an output. Or you've heard of DALL-E or Stable Diffusion, right? These take as input text and then spit out an image. Okay, or OpenAI's Whisper, right? This is something that takes as input speech, right? Speech signal, audio signal, and spits out text, right? So these are sort of a more general, it's a generalization of LLMs. And the foundation model recipe, right? So if something's going to be called a foundation model, then basically you're going to lean on 5 different desiderata. So one of these is that it's pre-trained, right? I can grab it potentially from the internet, I can download the weights from the internet, or it's pre-trained on a very large corpus of data. It's typically trained using something called self-supervised learning, which I'll give a link to in a bit. It's generalizable, the idea that I can use this pre-trained model and maybe prompt it in a different way, or maybe do like a very little bit of fine tuning, and I can use it for many, many different tasks, right? There've been a lot of evidence showing that you can use, for example, like a GPT-4 or GPT-3 even for things like planning or like traditional operations research styles of problems, even though it wasn't trained to do that, right? It wasn't trained to ship containers across the world in some like semi-optimal way, right? But it's generalizable in the sense that it does a pretty good job at doing that if you play around with it a little bit. It's adaptable in that same sort of vein. It's large, and I have air quotes around the large here because this is, obviously a moving target, but in general, this is like a very large model, and it's very large in the sense that the data that it was trained on is also quite large. And then often it's going to be trained using something called self-supervised learning, which is going to relieve some of the burden of going through and hand labeling potentially all the sort of data that you would have to do in a traditional supervised learning task. And I invite you to check out this very recent survey of sort of how self-supervising SSL works, and how you might be able to use it if you're going to try and train your own models. And this is a nice shout out to some friends of Arthur, including Arthur ML fellow Avi Schwarzschild, who's a co-author on this with folks like Jan LeCun. So that's all. If you hear foundation model, this is just, it's pre-trained, it's generalizable, and it's big. You can use it for a lot of things. That's basically it. Now, coming back to LLMs, if I wanted to get started using an LLM, okay, and we're going to assume probably you're not going to train your own, although we're seeing a lot of that in industry as well, which is, I want to know exactly what data went into my model. Maybe I don't trust sending my data to some other provider. Maybe I do have the ability to run this internally, so why don't I just train my own, right? But for now, let's assume that you're not. First, you should understand your application, right? Are you doing like a text-to-text problem, right? Are you summarizing emails, or are you doing text-to-image? Are you trying to create, creative for a marketing campaign, and so you need images or video, and so on? And so that'll give you basically a list of potential types of LLMs or other foundation models that you could lean on. A question is, are you going to have frequent updates to the underlying knowledge within this, right? So if I'm creating, say, an educational tool that's going to help I don't know, an 8th grader understand calculus or something like that. Well, calculus, the core of calculus isn't changing that much over time, and so I won't need frequent updates potentially to the model. But maybe if I'm doing like a stock trading bot, maybe I do need to ingest information either into the model itself or allow it to have access to some sort of knowledge base or a vector store with frequently updated information, right? And that's going to make specific changes to the architecture choices that you make. How much does trust matter? And that means trust in your user, and that also means trust in the information that comes out of the model itself. You may have heard phrases like prompt injection or malicious prompting, right? These are issues where a user may implicitly or explicitly manipulate the model in a way that it will spit out information that maybe it shouldn't be spitting out for a particular task. You should quantify in that vein things like reputational risk, like what if private data is leaked? How bad will that be? What if toxic content is generated? How bad will that be from a legal point of view, from a reputational point of view, if that hits the presses, that kind of thing? And then finally, what sort of human feedback can I get from the model, right? So at the end of the day, especially with large language models, you're generating text content, right? And I'll talk about this a bit more, but evaluating that text content for a specific task, there are obviously metrics for doing this, but in general, it's pretty difficult to evaluate if an LLM is quote unquote performing well or not in a quantitative way. And so at Arthur, we have some novel methods for doing this, but this is a very active area of research in general. So understand your application. Decide on the right approach, right? So I mentioned, we'll for most of this talk, assume that you're not training your own LLM. Many people are just doing sort of API access to a base model, right? So this would be, your OpenAI ChatGPT interface that many folks on this call have probably used before. And that's to a base model. So that's going to be like the ChatGPT model that is currently deployed. And you can manipulate it, not in a bad way, but you can manipulate that by changing the way that you prompt, right? So you can do prompt engineering to get different outputs from it. But at the end of the day, you're hitting that base model. You could do an API to a fine-tuned model that's hosted elsewhere, right? So this could be, I think, OpenAI, for example, charges like 4 times more per token if you fine-tune. So fine-tuning just means that you're going to either do some instruction fine-tuning, which is going to try to basically say, hey, you're going to be a type of model for a particular type of task, only do this kind of thing. Or you're actually going to fine-tune it by bringing in additional information, like additional, say, documents or your email or stock information from the last day, something like that, and then changing the model, actually continuing to train it a little bit to scoot it in a particular direction. Both of these are going to have concerns about privacy, right? At the end of the day, especially if you're hitting like the public OpenAI endpoints or the public Cohere endpoints or the public Anthropic endpoints and so on, you're sending private data to a third party. So there are obviously privacy concerns with that. And these are being addressed, at least in PR, by these large companies right now. And there are cost concerns as well, right? So somebody else is running this for you. Maybe they're going to get some nice economy of scale versus you spinning up your own instances. But controlling cost is certainly an issue there as well. And then finally, you could, train from scratch, right? So at Arthur, we're friends with a number of companies that do, from scratch LLM training. Mosaic ML is a big one that's been in the news recently. And you're going to have questions like, hey, that is going to cost money, right? Training an LLM costs money. Do you have enough data, right? Is that data clean enough, right? When you talk to these LLM training companies and people who train LLMs in general, like the big issue is actually like handling the data, making sure the data is representative, basically, of the task that you want to solve. And do you have enough compute, right? You actually have to train this thing. So running it is one thing, right? So inference is not free, but training is a totally different beast. And so for many, that'll be sort of out of scope, at least for the foreseeable future. Great. So you've understood your application. You've decided on the right approach, right? Am I going to use somebody else's LLM or am I going to train my own? Now, evaluation, right? Evaluating the LLM. So cost is a big one. Trying to estimate the cost for a particular use case. What if you have vendor lock-in and the cost gets jacked up over time? Right now, that's not happening because there's good competition in the space, but who knows what the future will bring. And looking at average and edge cases here, I think is a big one as well, right? So as, for example, companies are increasing the size of the inputs that they can put into these models, your use cases might also increase with that, right? And that might increase costs, right? Task-specific performance, right? So there's kind of the general, like, how good is this model? How expensive is it? How fast is inference, and so on. And then there's task-specific performance as well, right? So maybe I'm a manufacturing company and I'm very interested in Q&A for internal workers who are onboarding at my plants, and they're going to ask questions about particular manufacturing processes, right? I really only care that the model is good at answering those questions and answering them correctly. I don't really care if it's good at planning vacations, right? And so evaluating accuracy, speed, cost, and overall performance there is good. And then robustness, right? So this is robustness to drift in the underlying sort of use cases. And this is also robustness to adversarial inputs, right? So if a malicious user comes along, can they manipulate the LLM to spit out, say, sensitive information or toxic content? And finally, deployment, and then proactive monitoring and reactive monitoring. Okay, so this is, I've made a decision on an LLM. I understand, right now how it might perform on a particular task. Do I have the infrastructure for deployment? Am I going to store inputs and outputs? Again, feeding 100,000 words into a model every time you use it. If you store that input and output pair, then that's going to add up quickly over time. Is the modal user experience good? Which is to say, if I have a natural user who comes in and is not trying to manipulate the system, are they leaving sort of with a smile on their face? Are they getting their answers, answered correctly? Am I detecting malicious users? Am I detecting malicious prompts? And over time, am I going to sort of improve my process, not just the LLM itself, but the entire application around it via implicit and explicit human feedback? So that's roughly speaking how I would and have gotten started with LLMs, and this is the recommendation that I would do there. Right? Every one of these bullet points is a very interesting sort of space to think about as well. So LLMs are seeing application in many critical business areas. Copilots, I already mentioned these, for non-code tasks, right? This could be a copilot for example, writing an email or planning out a travel application, or there have been some even sort of higher risk applications that I've seen, like a copilot for therapy, right? So these are very, very, it's early days for a lot of this content right now, and it'll be interesting to see where society comes down on what can and can't be powered by ML in general, but also LLMs. Marketing content, I mentioned this as well. So doing reach out emails or doing creative generation if you're using foundation models like Stable Diffusion. Code Gen, mentioned GitHub Copilot already. Many of you have seen, this is a great democratizer for being able to program, right? So there's a company, Replit, out there that has their own LLM that they're using to do what amounts to close to no code, but like kind of lightweight code completion to help folks really onboard onto coding. It's pretty cool to see. Summarization, creative generation, customer servicing. This is a big one that we see with a lot of customers. Search, right? So if you've used the new Bing, or Google now has this as well. You can have a better natural language interface than traditional search. And so this is often going to connect out into some sort of data store knowledge base. You may have heard of vector stores to create results. Legal and compliance, right? So helping to understand legal documents or helping to understand people falling out of compliance based on text chats, right? This is something that we've seen in the finance space a lot. Financial analysis. And like I mentioned, traditional sort of operations research style questions as well, right? So planning, clustering, EDA, and things like that. So pretty cool to see these coming into production very, very quickly. And so at Arthur, we've seen an almost top-down motion to pushing LLMs into production, which is very, very exciting. From an ML point of view, often you have to make the case as a data scientist to your boss, who makes a case to their boss about the business value of a particular ML application, and then you do testing and so on. We're also seeing this now top-down process from the C-suite saying, hey, how can we leverage these in our business? And that's been a real explosion in the last 3 to 4 months. Cool. So they sound great, right? Can we have our cake of using these foundation models, maybe that somebody else trained, to solve all of our problems? No, not necessarily, right? So sometimes things do go wrong. And I have a couple of just screenshots from the internet here. So here's one, which is a new AI built on GPT-4 to do Q&A. So how can I help? Hi, I lost my password. LMFAO, which is laughing. Well, it's a version of LOL, which I am too polite to say on this webinar, but that's probably not an appropriate response from a chatbot. Here's PayPal's virtual agent, I think also based on a GPT-3 or GPT 3.5. Hey, I got scammed. Great. Probably not the right response. we may have all seen in the news this Samsung banning firm-wide banning staff's usage of these API access LLMs because folks were using them to do things like code summarization or code fixing on proprietary code from Samsung's side. So that was getting passed to OpenAI, and this is obviously a violation of a number of sort of privacy issues. There are lawsuits, right? So lawsuits currently against many of these foundation model providers. So here's one of the earliest ones was filed against Microsoft, GitHub, and OpenAI over GitHub Copilot, claiming that Copilot was trained on code that wasn't licensed in a way that was friendly to training. And so it's going to be interesting to see what pops out of, well, what does it mean to have a model trained on private information? Am I now using that, say, private information or incorrectly licensed code to generate new content? And am I violating the license? I think we're going to see a lot of progress in this space with the law catching up. And then, like I mentioned, malicious prompting. So here's a recent one. I think somebody on Reddit came up with the Do Anything Network, or DAN, where you can convince ChatGPT that it's the Do Anything Network, and it suddenly jailbroke it, basically. It took off all of the safeguards and allowed a user to create basically toxic content. So a lot of things can go wrong. And at Arthur, this is something that we've been thinking about, well, for quite a long time. What can go wrong with ML systems in the sort of traditional ML ops space, right? Like issues of bias and fairness and issues of, this is a black box model. Can I interpret it or explain it in some way? Is it robust to data drift? All of those problems still exist with LLMs and more, in the sense that now you're opening up this endpoint to natural language. And you're using this in a number of sort of novel, newer at least, tasks and applications, and it's just hard to evaluate what's going wrong. So it's always important to keep an eye on things, basically, when something's deployed. So significant challenges in the LLM space: toxic content generation, hallucination. I don't love the term, and I hope we as an industry move away from it. But this is basically confidently being incorrect, so spitting out facts that just aren't true. Leaking sensitive data. This is one of the biggest issues that we hear from our customers. I don't want to have a user be able to access, say, specific salary information for John, but maybe I want that user to be able to access average salary over a firm, something like that, right? So what is sensitive data? Can I track when it's actually popping out of the model? Can I prevent that from happening, and so on? And this is a focus for our firm as well. Fine-tuning is difficult and costly. Deploy time speed, right? These are very large models, and inference can take quite a long time and be very costly. Manipulation and robustness, and then also just even evaluating vendors and approaches is difficult, right? We have a number of sort of benchmarks that are out there right now, but none of them are perfect. And these vendors are changing these models all the time. And so, we need to keep these up to date. And so it's very difficult, especially for, somebody who's not, neck deep in this sort of field, to keep track of these. So I also want to pull out another aside here, which is what data did the model see, right? What other ethical considerations are there? And so data sets are often scraped from the internet. Sometimes they're ignorant or, not quite fully aware of licensing, right? So GitHub Copilot tried, at least allegedly, to follow licensing for code. Adobe Firefly is really trying to sort of adhere to sort of ethical creation of the model, in the sense where ethical to them is basically making sure that you're not violating grabbing art from the internet that isn't licensed, in an open way. Midjourney, I think, famously just scoops up everything from the internet and doesn't really care about this. We're going to see a lot of sort of norms form around this in the coming months. Even when the data used is quote unquote okay, it may result in unexpected incorporation of sort of data that you might not think should be in a model. So there's a really interesting Washington Post article that came out recently, and I'd encourage everyone to read this, which does a deep dive into Google's C4 data set, which is the backing data set for quite a few of Google's models. And you can see here, the most common source of data for that model is coming from patents.google.com, right? So this is a very large sort of trove of the various patents in the USPTO, and I think international as well. Wikipedia is fed into this. The New York Times, the LA Times, the Guardian. These are things that you wouldn't be surprised are in a model like this. But if you do a deeper dive, you end up seeing that, like, Florida's voter registration database is in the top 100 sources of data for the model. And right, that is public information, but maybe it's a little bit, I don't know, ethically gray, if you will, to put that into the model itself, right? This is public information, but now you're opening it up in a very searchable way, and it might at least result in some sort of odd behavior popping out of the model. And the WAPO article also says, hey, the copyright symbol, which denotes a work registered as intellectual property, appears more than 200 million times in this data set. And now, obviously, some of those are going to be okay, right? Like it's fine to have the copyright symbol appear in the data set if you went to the copyright symbols Wikipedia page, but probably some of those 200 million copyright symbols are, pertaining to actually sort of IP murky inputs to the system itself. Bias is also an issue here, right? So this is bias in the information that's fed into the model. This is also bias in the token generation process, so what's coming out of the model. It's a perennial issue in language models. It's a perennial issue in vision models as well. And then I won't get into this in this webinar because of time, but there are also obviously sort of job displacement and other sort of disruption concerns that arise from the use of these models as well. In terms of deployment challenges, roughly speaking, you can think about three sort of verticals for deployment issues. So one is pre-production. So first you're validating and testing models, right? Like if I were to put this into production, how well would it perform? Where are the pain points? Where would it perform poorly, and so on. During, at prod, basically, you do have this user experience, right? A user is using an application powered by one or more foundation models. Are we protecting them from malicious content? Are we protecting the model from malicious user content? Are they leaving with a good experience, and so on? And then post-production, or sort of an ongoing experience, right, is going to be analyzing user interactions with the model and using that basically to improve the model, using it to improve the application, and so on. That's what Arthur, we said in all three of these spaces. Here are some quick pain points. I'll just go through these real quick. This is coming from extensive both market research on our side, as well as obviously working with customers who are deploying LLMs as we speak, or who have LLMs in deployment already. So at the validation phase, I might have a problem like, hey, I can't tell if model A, ChatGPT, is better than model B. Let's say the DALL-E model that came out of Databricks, right, an open model. And I can't tell that because it's going to take forever. I don't have enough people to look at this. The input space is enormous. There's no way I can properly sample it, and so on. Right. So my manual reviews are only going to sample a very, very sparse set of the possible natural language inputs to a model. So how do I select those even? And then I'm also worried about, what if OpenAI changes ChatGPT, right? Like overnight, maybe they're doing a little bit more fine tuning or RLHF or whatever, or maybe the values of Sam Altman changed and, OpenAI starts doing something different with their model. How is that going to input? How is that going to change how my application is working downstream? And so we have a solution which allows us to automatically test different LLMs, evaluate LLMs, understand sort of failure modalities for those LLMs specific to a customer's tasks and also overall. And this is coming through as sort of an automated test suite that we put together. So happy to point people to that as well. From a user experience point of view, we worry about bad outputs, right? I have no way of preventing bad outputs in production. And I'm saying bad here in general because bad can also obviously be task specific, right? I worry about private data and sensitive data leakage. Almost every customer we talk to worries about this. Toxicity is a big one as well, although to their credit, the OpenAIs and the Anthropics of the world have done a very, very good job, I would say, of really tamping down on the model, maybe even too much to prevent toxic content from being generated. So we recently launched Arthur Shield, the first firewall for LLMs. And this is a gating function, basically an in-band solution, which will both detect and then mitigate a lot of these issues. And nothing is perfect in this space. Anyone who claims that they're perfectly detecting all malicious inputs or outputs is lying to you. But we are at the forefront of that through sort of a novel R&D driven approach that we've taken for 4+ years and expertise in that space. And so we're really, really looking forward to working with customers to understand and continue to harden our system there. And then, once you're in production and watching over this model, you should be collecting information from users, right? So measuring performance, measuring, user experience. These are all pain points that we're hearing the market have. And so, this is the bread and butter of many MLOps companies, and this is the bread and butter of Arthur as well. We've been doing this for a very long time, which is, scalable ingestion of data, scalable ingestion of human feedback, implicit and explicit, and then using that to make both descriptive analytics for how a system is working and prescriptive statements for how you should change or potentially change such that you, say, improve. So in the interest of time, happy to talk about some other sorts of content that Arthur offers as part of our solutions. We have notebook-based access, either through an SDK or API access. We also have a very nice UI if you'd like to be able to present this to, say, a product manager or to the C-suite, going over various metrics, making prescriptive statements about how an LLM might be improved or an LLM application might be improved, and so on. And like I mentioned, we have a sort of a test suite that we can use to evaluate LLMs as well. So please do, if that's a problem that you're facing, check that out. We also have techniques from explainability, techniques for anomaly scoring to understand sort of a model's performance relative to both natural distribution drifts of, say, the inputs, as well as malicious inputs and things of that nature. Roughly speaking, this is how we see ourselves fitting into sort of a modal LLM application. So this is sort of the environment of LLMs. On the application side, we have the user who's dealing with some prompts, or maybe they're using tooling, maybe they're leaning on LangChain, which we integrate with, and to hit a particular LLM or set of LLMs. Arthur Shield is going to sit in between the LLM and the user, trying to understand, hey, is this okay input? Is this okay output? And then mitigating or blocking accordingly. At the deployment layer, we worry about the LLM's cost, inference speed, and so on. At the development layer, this is the selection of an LLM or the training of an LLM or the improvement of an LLM through our LHF. And we sit between that layer as well, which is this sort of evaluation and test suite that we have for testing these out. And I'll leave with this sort of slide showing broader challenges in the LLM space. Trust and correctness is a huge problem here. This is a huge problem in machine learning in general. This is also a huge problem in the LLM space, right? So hallucination or veracity of the outputs. Measuring the uncertainty in outputs, right? So there's this fun quote that I like to use from an econ professor, so I don't feel bad saying it. So LLMs are like economists, always confident, sometimes right, and that's still the case. Being able to detect when that's the case is a core focus of Arthur, and it's also sort of a core focus of R&D right now. Alignment, right? So aligning with whom, right? So are we OpenAI aligns in one way, Anthropic aligns in a different way. They have this Constitution AI that came out recently, which is a sort of an interesting approach to what I would say is more traditional value alignment. How do I track how the model is changing over time as it continues to update, right? And so here's from Anthropic's core views on AI safety. We do not know how to train systems to robustly behave well, right? So that's one of the biggest players in the space saying that. Measuring performance. So this is more than just some loss function. And there are some metrics that exist there. Arthur has a number of metrics, both public ones and also novel methods for doing evaluation. But this is still pretty tricky, right? And so there was a nice announcement by the White House supporting a red teaming event, which will happen at DEF CON in August, which is going to be sort of the largest hardening of some of the major LLMs that are out there. So people basically trying to break them and trying to understand where they're performing well and where they're performing poorly. But I will quote Jonathan Frankel, who's the chief scientist of one of these LLM training companies, basically saying, so blue and rouge are sort of core metrics from NLP, basically saying like these are the S word, if you will. He's not happy with evaluation metrics for LLMs. And so this is an interesting space to operate in for sure. And then finally, there are a number of changing economics when LLMs come into play. Right, both on the training side, right? Microsoft invested $10 billion in ChatGPT in OpenAI, and it's been rumored actually that Sam Altman has been saying that he wants to have $100 billion raised to basically train larger models. But also running these, right, as an LLM for X application, running these is much more costly in many cases than a traditional ML model. And so understanding those costs, understanding the trade-offs between, should I spend a lot more for better outputs from a larger model, or should I trim that down, have a smaller model, maybe poorer outputs, but save 10 times the amount of money? Making that decision is a tricky thing to do as well. And so at Arthur, this is something where we're actively researching all of these. We have solutions for all of these right now as well, but they are going to continue to improve, and we look forward to partnering with potential customers and other thought leaders in the space to push this forward. So again, a quick shout out. We did just launch Arthur Shield, the first LLM firewall for LLMs. And we'd love to have folks kick the tires and potentially use this product in production. So at that, I'll leave this for Q&A. Oh, I see one question already. What does the user experience for configuring these Arthur services look like? Are data leakage, toxicity, et cetera, detected autonomously? Or is there a user feedback reporting functionality that closes the loop for the Arthur functionality to be improved? Yeah, so we, out of the box, have various detectors for well, the things that you mentioned here, right? Like toxicity, sensitive data leakage, PII leakage, malicious prompting, prompt injection, things like that. But at the end of the day, you as a domain expert are going to know what you need better than some general solution that's out there, right? And so BYO for some of these sorts of detectors is also supported. And that can be BYO in the terms of a knowledge base that you bring in. That can be BYO in the case of a detector that you bring in. Maybe there's a specific thing that you care about that is very, very specific to your vertical. Or that can be in terms of prompts as well, right? So a lot of prompt engineering work is used to make a foundation model be task specific, and that can be a BYO on the prompt side as well. Now you also ask about human feedback. Yeah, so at the end of the day, like I mentioned, evaluating outputs is very difficult, and it's been difficult in language for a very long time. It's going to continue to be difficult, and so having a user be able to say yes, this is good or not good is obviously important, right? And if you go on to like ChatGPT, you'll see the thumbs up or thumbs down there as well. And so yeah, this is a necessary component of building out a task-specific test suite for evaluation of an LLM that's in prod for sure. A question. What are your thoughts on pace of deployment and societal risks posed by LLMs, and how do you believe this issue should be addressed? Yeah, that's a really, I mean, this is an interesting question, and it's not even specific to LLMs, right? This is a question that's often asked when technology, we have like a leap in technology, right? So the pace of deployment, I personally am pretty happy to see the open source community, especially, really pushing forward to push these models, well, to make them more accessible for one, and to sort of understand where they're failing for two. And this is an interesting question about technology in the sense, like, at what point should regulators come in and really start regulating things? I think you're starting to see the regulatory landscape wake up to this, right? The White House has put out, various blueprints. Many agencies, regulatory and NIST, for example, a non-regulatory agency, has done an outstanding job putting out a lot of sort of understanding the risks of AI kind of documentation. I think we're going to start seeing some laws be pushed through here right now. But I would hesitate to over-regulate, right? This is an exciting space, and I think there's a lot to be gained still by allowing us to iterate very quickly. Now, let me put a semicolon there and say that, co-founded a monitoring company, basically, right? So this is understanding a company that is firmly concerned with making sure that these models, LLMs and otherwise, don't go off the rails. That's very, very deeply concerning to me and also motivational to me, right? So a lot of our initial pitch was around fairness and bias in machine learning, and those concerns are still paramount in the times of LLMs. Some of that can be solved with regulatory actions, and look at like the CFPB, right? Look at the SEC, like look at some of these regulatory agencies. They already have stuff like this at DOJ. And some of this, I think, has to be solved by industry, right? Like by partnering with experts in specific verticals and developing sort of monitoring solutions that allow us to understand pain points. A lot of questions. When performing model comparison, how do you assess the results that are most important for the person trying to select an appropriate model for a use case? Yeah, this is tough, right? So I would say, and I think I roughly broke this in two for the webinar presentation as well. So we have general performance. So this is using sort of general metrics and approaches to understand and compare to LLMs. And so that could be a test suite with general gold standard data, general prompts, general metrics, like the blues and the rouges of the world. Yeah, that's one. Using LLMs to judge LLMs is a very promising technique as well. Having human evaluation is a third promising technique there. I think any sort of test suite is going to have all three of those, and that's very important. Now, calling out to humans for feedback, this is an active area of research where, I'm hoping that we as a company are going to start leaning a little bit more like active learning style approaches to calling out to specific areas of high uncertainty. And I'm happy to dive into that in sort of a separate discussion as well. But it's going to have to be all three of these, right? So automated traditional metrics, sort of novel metrics, leaning on the ability for these models to basically evaluate other models, and then human evaluation as well, right? So understanding when to call it to humans. And then that's in the general case. In the task-specific case, it can be BYO in terms of like, you have your own gold standard for manufacturing data or whatever that you bring in, maybe with your own metrics as well. And, that's more like traditional ML test suites at that point. How can the development and deployment of LLMs strike a balance between responsible AI practices and preserving user data privacy? Okay. Yeah, so again, a lot of these questions about sort of like user privacy and RAI practices, they really do pertain to a lot of basically ML in general and not just LLMs. So I think, one, it has to be, there's going to be a regulatory solution for some of this. Two, there have to be community norms that are developed, right? At the end of the day, it is definitely possible. Like this is very, very democratized technology, right? Like Microsoft recently released basically their training, like their entire training code for being able to train these large models. Mosaic comes to mind as well as being very, very open with their core sort of optimization techniques. Nothing's going to stop somebody from going out there and training their own version of this. And so we need community norms on top of regulatory norms to push this forward. Three, I think, is also a communication issue, right? So this is an issue with all stakeholders. This is a perennial issue when it comes to privacy as well, which is making people understand what these models can do, making people understand what data is going into them, making people understand what data can be aggregated out of them by being able to basically snarf in the entire internet. Some of this is communication to the public as well. And this is an issue we faced in the fairness and machine learning community for a long time as well, which is like, what does it mean for a classifier to, whatever, have demographic parity? Right? If you talk to non-experts, they're going to have a very different belief as to what that means and the impacts of that, say, constraint or that regularizer and objective to downstream impacts versus like an expert. And I think we're going to need to see, and to their credit, the Chi HCI community, I think, is really, really waking up to this with like HCXAI and things like that. We're going to really need to see a lot of like communication and like behavioral things on the human side as well. So to summarize, a little bit of regulatory, a little bit of norms, a little bit of communication, and then obviously understanding sort of like these test suites and these metrics and understanding like where things are going right and where things are going wrong from a quantitative point of view. One of the proposals for legislating AI to be able to explain the outputs, but sometimes the output isn't understood even by those who build the models. But that doesn't mean that the output is wrong. How can you legislate that? To be clear, I don't personally believe that legislation and regulation are going to be the first and most important sort of like line of defense here. But I think, going back to my last question, we need to develop metrics that allow us to say something is good or bad, it's performing well or it isn't performing well. My guess is a lot of the legislation is going to come down, though, in verticals. It's not going to be sweeping overall generalized sort of, you can or can't do this for exactly the reason that you're bringing up. I don't really know what a good or a bad output is in general. But for a specific task, I can make statements about, hey, if you have this kind of application built on this model and the downstream impact does this concrete, verifiable, measurable thing that society has made a normative statement saying this is bad, then I can legislate that at that point. So my guess is it's going to be more like systems level legislation for specific verticals like finance, like healthcare, and so on. Are there any grounding and citation solutions out there which help with making sure that models are not confabulating and can be used in high-risk apps like healthcare and finance? Yeah, so calling out to gold standard sort of knowledge bases, I think is going to be a necessary, maybe not sufficient, maybe you need more than that, but at least necessary component of anything like this, right? And so this is why you're seeing a lot of these like vector store startups, raising a ton of money, is because people are leaning on this idea that, hey, to keep my model up to date and to reference out to gold standard data, I need to actually reference out the gold standard data and be able to bring in new data very, very quickly. And so if I were to have to choose exactly one technology, it would be stuff that is based on that, right? Like calling out to some documentation that you brought on your own, or calling out to a particular whatever electronic health record that says, yeah, this patient does in fact have type O blood, something like that, where you're able to actually link into the core data, either data that was going into the actual training process for the LLM, or data that you brought in alongside. You didn't train your own LLM, but you have access to your own, say, electronic health records or whatever. Bringing that in and referencing out to gold standard data, I think, is going to be a necessary component of anything that does that. The session was very insightful. Thank you for taking the time. Oh, nice. Can I request you send the presentation deck? Oh, yeah, sure. Yeah. I mean, this was recorded, and I'm happy to share the deck as well, of course. Cool. Any other questions? Thank you all for coming, and looking forward to additional webinars in the future. And one last shout out to Arthur Shield, which we just launched. So this is the first firewall for LLMs. Again, would love to partner with folks to really push this forward. Thank you.